There is a body of water in East Africa famous for a specific lethal phenomenon, calcifying the remains of animals that die within its depths. Welcome to PeoplePod. We're looking at Lake Natron, sitting right on the border of Tanzania and Kenya inside the Gregory Rift. The surrounding landscape is defined by its physical extremes. Seasonal rainfall here is highly irregular, and local temperatures frequently surpass 60 degrees Celsius, or 140 degrees Fahrenheit. Between the extreme heat and erratic climate, the geology should actively reject complex biology. The mechanics of the lake start with its plumbing. It operates as a closed basin. Rivers and mineral-rich hot springs flow into Lake Natron, but the water has no outlet. Everything that enters is trapped. This cross-section shows trapped water evaporating. Heavy minerals from the bedrock are left behind, concentrating at the bottom. These compounds drastically spike the alkalinity past a pH of 12, creating a caustic brine that preserves dead organic matter. The environment effectively becomes a giant sun-baked chemical vat. Yet, if you look closely at the surface of the lake, those deep reds and bright oranges aren't chemical runoff. You are looking at a massive bloom of living organisms. The water is filled with halophiles, or salt-loving microorganisms, specifically extremophile cyanobacteria perfectly adapted to survive in extreme salinity. They use a distinct red pigment to process sunlight for photosynthesis. These bacteria form the base layer of a highly specific food web, primarily producing a blue-green algae called spirulina. There are even complex organisms living here. Right at the very edges of the hot spring inlets, 2 endemic species of alkaline tilapia manage to survive the blistering heat. The caustic chemistry doesn't prevent life. It fuels a completely self-contained, highly specialized biological sanctuary. The primary beneficiary of that sanctuary is the lesser flamingo. They gather in massive flocks in the shallows to feed exclusively on that red spirulina algae. This chart shows the global stakes. Up to 2.5 million birds, which represents 75% of the entire global population of lesser flamingos, rely on this single lake as their regular breeding ground. As the water evaporates during the dry season, it leaves behind evaporite islands. The flamingos build their nests directly on these isolated salt crust rafts. This is where the lake's toxic nature becomes a physical asset. The surrounding caustic brine acts as an impassable moat. Land-based predators simply cannot cross the burning water to reach the nests. The lesser flamingo relies directly on the lake's deadly toxicity for its continued existence. However, the exact chemical compound that creates that protective moat, sodium carbonate, is highly prized by the commercial washing powder industry. This commercial value led to a major development proposal by Tata Chemicals. Their plan was to pump water directly from the lake, extract the sodium carbonate, and export it globally. An extraction operation of that scale requires heavy secondary infrastructure. The proposal included housing for over 1,000 workers and a dedicated coal-fired power station built directly on the lake's edge. Pumping the lake at an industrial scale would draw down the heavy minerals and dilute the unique chemistry, effectively draining the chemical moat that keeps predators away from the breeding grounds. In response, a coalition of over 50 global conservation groups mobilized as the Lake Natron Consultative Group to halt the factory's construction. The industrial project was paused in 2008 to allow for a Ramsar wetland review. But today, the ecosystem still lacks formal, permanent legal protection. Even if the factory is never built, the lake faces severe risks from planned hydroelectric dams on the upstream rivers and increased silt from agricultural logging. Both developments threaten to dilute the water. If human intervention successfully dilutes or tames the caustic waters of Lake Natron, it guarantees the collapse of East Africa's lesser flamingos. Thanks for watching PeoplePod.